You can write down the complex number on a complex plane as a plus bi. This is called the rectangular representation, simply because a and b are just like sides of a rectangle. This representation resembles a coordinate system, and yet these weird coordinate system-like numbers are still numbers. Here is a diagram, a number theoretical representation of where complex numbers lie, or where they are located among the other numbers. It's much more general than any other number we've seen before. But if you're interested, complex numbers can also be extended. To be fair, this is where the game starts, because this is the first extension that we have realized. What about other ones? How far can we go? These are all questions for another time. But right now, I'm gonna blow your mind. How do we divide a number by I? Because we've seen multiplying. That's just turning by 90 degrees. That's easy. What is division? Well, division by a number, any number, is just multiplying by 1 over the number, or the number to the minus 1 power. We already know that. So the question is, what is 1 over I? 1 is minus 1 times minus 1. Minus 1 is I times I. So 1 must be I to the 4th power. This makes exact sense as you turn around by 90 degrees 4 times. That is 360. That comes back exactly where it was. But I to the 4 over I is just I to the 3. That 3 times 90 degree rotation. And that is equal to minus 1 times I. That is equal to minus I. And now we know that minus I is equal to I to the minus 1 power. This is an remarkable property of I. And also, that means dividing by I is just the same as rotating in the negative direction by 90 degrees. Why? Because minus I is down there at minus 90 degrees. If your mind was not blown by this, well, I have an even bigger mind blow for you. Get ready for the polar representation. If a point on the complex plane could be defined by a vertical and a horizontal part, then sure enough, it can be described by a diagonal. And all we need is to find the length of the diagonal, and the angle. The length is just good old Pythagoras, and the angle is just good old inverse trigonometric functions. You take the imaginary part as the height of the triangle, and the real part as the base. So in this arrangement, the angle is given by a tangent function. The tangent of the angle times the base is going to give the height. Rearranging it to the angle, we simply get that the angle is equal to the arcus tangent of the ratio of the imaginary part over the real part. As a result, we have an angle and a length which we identify as a radius. An angle and a radius will give you a circle, exactly a point on a circle. Varying the angle means going around, and varying the radius means making it bigger or smaller. So shrink and turn, that's the key word. And now you're beginning to see where this whole lecture is going. There is this new kind of number that describes points on a circle, and we have just happened to learn a lot about the circle.